I think you'll like it. I think you'll like it. It's very cool, but I absolutely love this stuff. I wish this is all we would do. Like, I love it so much. Of course, it's a one-day thing. Hi. Hey, thank you. What is your name? Max. Okay, thanks. All right. Okay. So this is my very, very most favorite thing, and I think you'll find it quite enjoyable too. Today we are going to be able to graph polynomial functions by factoring and looking at their zeros and the leading term. Because we know about end behavior, we have an idea of how it should look, okay? And the idea is that we get to do this by hand and produce a graph that is very close to what the calculator will show you, which I think is really, really cool. So zeros are the x-intercepts of a function. So the x-intercepts of a function are called zeros. So they have two names. We can call them zeros. We can call them x-intercepts. But on this graph here, we see that we have 1, 2, 3 x-intercepts, or in this case, 3 zeros. There are 3 zeros, and those are the places where the y value is 0. That's why we call them zeros. If I were to imagine that this was an ordered pair, it might be like 3, 0. The y value is a 0. That's why we give them the name zeros. Okay. So we have 3 zeros on this little example. A polynomial function of degree n can have at most n real zeros. If I have a polynomial function like this one, which might be 3x cubed plus 2x minus 1, maybe this is this graph, I don't really know. Maybe plus 1 is more realistic. Because it has a power of 3, it will have at most 3 zeros, okay? At the very most. Whatever that highest power is, that's how many zeros we could have. Okay, this is weird. An even degree polynomial has an even, I don't know why this is important, number of real zeros or none. I know, yeah, an odd degree polynomial has an odd number of real zeros. That's really lame. So here she says, even degree polynomial has an even number of real zeros or no real zeros. So I'm going to talk about that for a minute because that is interesting. So let's say I have a little sketch of a graph here, and it's a parabola, and my parabola is up here sort of floating. If it's floating, does it have any zeros? No. So this has 0 zeros. It doesn't have any zeros because it's not crossing the x-axis. It doesn't have any real zeros. All right? They ain't real, but they could be imaginary. Okay, so this is where real and imaginary get mixed up here. Here we have 0 real zeros, but there are 2 imaginary zeros. Okay, well, let's talk about a little bit more. The solutions to the equation f of x equals 0. So this is taking our function and setting it equal to 0. That's saying, hey, if the y value is 0, this is going to give us the zeros of the function. And we also call these roots. So there are 3 different names for these zeros. We can call them x-intercepts. We can call them zeros, but we can also call them roots. So this also has 3 roots, or 3 x-intercepts. And you can kind of imagine we call them roots because this, you can imagine this is like the ground, and that's where the roots are hitting the ground, like of a tree, you know? So it's like the roots, yeah, anyway. That's, all right. We call them roots. All right. Okay. So they have 3 different names, which is kind of weird. I don't want to talk anymore about that. Let's see. So here, for example, we have this polynomial, and what we want to do is we want to set it equal to 0 so that we can figure out what the roots are. Oops. Well, no, 24x. So what we're doing is we're taking f of x and we're setting it equal to 0, because what that means is, hey, if the y value is 0, we're going to figure out what all the x's are that make it 0.
Oh, I was thinking of, like, we wanted to see what we were replacing x with 0. So that it would...
Right. So to replace x with 0, that would look like this. F of 0 equals something. So this is saying if I take the x and plug in a 0 in place of the x. Okay? So f of x equals 0 says, hey, take the f of x and it becomes 0. All right. All right. If we see something like this, we want to try and factor it. Well, when I look at these three terms, what do they have in common? An x. So they have a greatest common factor. So that's what we're going to look for. I'm going to take out the x. And if I take out the x, what do I have left behind?
X squared plus 5x.
Minus 24. Good. And now we have a trinomial, and that is something we can double bubble. So that's what we do. So we're going to double bubble the leftovers here. X times x is x squared. And what times what gives me negative 24? What times what is negative 24? Yeah, 8 times negative 3. That's an excellent choice. Positive 8 and negative 3. What we get then, these right here, when we factor, these are what are called the linear factors. Linear because they're all x to the first power, x to the first power, x to the first power. So those are called linear factors. And if we have the linear factors, then we can also see the zeros. The next step here is just to set each bubble equal to 0. We would get x is equal to 0. We would have x plus 8 is equal to 0. And we would have x minus 3 is equal to 0. X equals 0 is a 0. It's done. What do I have to do with x plus 8 equals 0? Minus the 8, sure. So we get x equals negative 8. There's another 0. And over here we just have to add the 3. So we get x equals 3. So those are our 3 zeros, which you can see really easily when you have linear factors, right? Like it's easy to go from the linear factors to the zeros. Super easy. This is our goal for everything in this unit. We want to be able to write everything with linear factors and then be able to get the zeros. Super easy. Okay? So let's practice. We are going to find the zeros of the function by factoring, and we are going to sketch. And I'm going to talk about that in just a second. Because if you know the zeros, you can make a sketch really easily. So here, to find the zeros, we set our function equal to 0. And what can I take out of the numerator, or the an x? Yep, we got a GCF. So I'm going to take out the x. What's left behind? X squared plus 3x minus 10. And from here, we can double bubble that trinomial. X times x is x squared. What times what is negative 10? Yeah, 5 times negative 2 gives me a negative 10. So positive 5 and a negative 2. So there's our linear factors. And then we just want to have the zeros. What are our zeros? 0 and positive 2. So here are the zeros. I maybe write zeros. Okay, there we go. Those are the zeros. Really easy. When you have those linear factors, it's easy to see. Now, the leading term, LT, stands for leading term. What is the leading term of our original function? X to the third. Yeah, that's our leading term. That's the highest power. All right, the leading term is x to the third. What should those arms look like? What should those arrows look like? Yeah? Should start low and end up high, just like that. And you know that just from the leading term. So what we're going to do to make a little sketch is I'm going to draw a very small graph. It does not have to be giant. I'm going to plot my zeros. So I have a 0 here at 0. I have a 0 at -5. I'm just going to plot it and label it. I don't need you to do tick marks. I just don't care. Okay, no tick marks. Just plot it and label it. And then 2 is going to be about like right here. So I'm going to plot it and label it. Okay. Now, when I have these linear factors, my graph is just hitting and passing through them one time. And what that means is I'm going to start low on the left. So I'm going to start down here in quadrant 3. And all I'm going to do is I'm going to pass through that first 0 that I come across. And I got to turn around and pass through the 0. And then turn back around and pass through the 2. And ladies and gentlemen, you just graphed a fantastic curve. That's all it is. All right? And you can check because you have a calculator and you can double check and be like, hey, did I do it right? Let's see. X to the 3rd plus 3x squared, 3x squared, minus 10x. All right? Hey, pretty good, right? Now, does it look identical to the calculator? No, but I didn't put any tick marks on my graph, did I? So I can't really say how high that mountain peak is, right? For instance, if I change my window and I make my mountain peak go to 30, and I graph, oops, sorry, let me check my window range here. That should be, let's go -10. I meant to change the maximum to 30. There we go. And now, hey, could my graph pass for that? Like, it's pretty good, right? Like, it's fine. Totally fine. All right? That's our goal today. Totally fine. Let's look at number 3. Number 3, you'll notice it is a trinomial. Okay? Very important. It is a trinomial. Does it have a GCF? It does not have a GCF. But it is a trinomial, so we're going to just start double bubbling right away. So, what times what is x to the 4th? Oh, okay, but what times what is x to the 4th? Oh, there we go. X squared times x squared. Beautiful. Okay, now you can answer your question, which was last times last has to be +4. What times what is +4? -4 and -1 gives us that positive. And then we can double bubble again. Yes, both of those are difference of squares. So x squared minus 4 is going to double bubble into what?
X minus 2x.
Yes, x minus 2, x plus 2. And then x squared minus 1 is also difference of squares, and it's going to factor into x minus 1, x plus 1. So here are our linear factors, and that means that our zeros are
+2 and -2.
+2 and -2, and
-1 and +1.
good. All right, so once again, I'm going to make a little sketch I'm going to do over here to the left. And just labeling, let's see, I got a -2 and a -1 and a +1 and a +2. So there are my 4 little zeros. And what's our leading term on this equation, on this function? X to the 4th. So what do arms look like on something that's x to the 4th power? Both arms up? Okay. So we know that it should do some both arms up. So what I'm going to do is I'm always starting on the left side, so I'm starting up high. And I'm just going to pass through the 2, the -2, turn around, pass through the 1, turn around. And it's sort of a W shape.
Wow.
Wow. And that's it. And it's super cool, and it's super fun. Can you check on your calculator if you're unsure how that looks? Sure you can. Do you need to? Probably not. Let me ask you a question. What's the y-intercept?
0.
No. 4. How do you get a y-intercept? Yeah, the y-intercept occurs when all the x's are 0. So when we plug in a 0 for the x, 0 to the 4th, minus 5 times 0 squared plus 4, we just get 4. So we get this ordered pair 0, 4. And that is the y-intercept. So you can see that on the graph there as well, which is pretty good. Okay. All right. You good with that? Okay. So, let's look at number 5. How many terms do you see on number 5? 4 terms. 4 terms. How do we factor with 4 terms? You part the red, yeah, you gotta part the red C. This is where we split it, and then do the greatest common factor a whole bunch of times here. So just looking at the GCF in front here, what can we take out of the first 2 terms?
X squared.
Yep, they both have an x squared. We can pull that off in front. What's left behind? X plus 5. And then on the last 2 terms, a negative 9 we can take out, and if we take out the negative 9, what's left behind? X plus 5. And again, double check. You can always double check by multiplying or distributing here. Negative 9 times x is negative 9x. Negative 9 times 5 is negative 45. All right?
Maybe x plus 5 equals x squared.
So you have x plus 5. They have that in common, so we can pull that out in front. And what does it leave behind? Yeah, it leaves the x squared minus 9. All right, what can we do with x squared minus 9? Split it into 2 bubbles. Yeah, so double bubble that. We get x plus 5, and then we have, how does x squared minus 9 factor?
1 of it.
X times x and, yeah, negative 3 and positive 3. So there's our linear factors. And what are our zeros?
Negative 5. Negative and positive.
Yeah, plus or minus 3. All right, cool. My leading term is x to the 3rd. So what do the arms do when we have that highest x to the 3rd power? Start low, end up high. Yep, so start low, end up high. And if we graph that, I'm just going to make that sketch here to the right side. I have a negative 5, negative 3, and whoopsie daisy, positive 3. That's kind of off there. All right, so again, x to the 3rd starts low on the left, so I'm going to start low on the left, passing through negative 5, turn around, hit up the negative 3, and then turn and hit the positive 3, and end up high. What's the y-intercept? Negative 45. Very good. Y-intercept is 0, negative 45. So way down here at negative 45 is the y-intercept. All right, easy or hard? Easy? Okay. I have to check something really fast to see. I love this stuff. I think it's so much fun. I have to see what we're doing today. I forgot to double check. Today is the 17th. 3.4. Oh, we're done. Well, how about that? Do you have any questions for me? Pretty easy, right? Yay. All right.